Okay.
We can't go to that.
This is just on the laptop.
Okay.
I will post this after
Okay.
probably tomorrow sometime. But before we start tonight, which is troubleshooting, and it's mostly a big demo, go through this different methodology to subnet, because what we did before is write all the ones and the zeros, right? Pain in the rear, right?
Oh, yeah.
We talked about, or in the book he talked about an increment. And an increment is just how many you have based on the number of bits. So the increment, see if I can get a pen here. The increment is how many. So if we have 1 bit, for instance, we have 2 in the increment, 0 and 1. If we have 4 bits, we have 16. And the really kind of cool thing about that is to find your subnet mask. If you have 16, so we subtract 16 from 256, we get 240. That's going to be the subnet mask. So the increment is how many. So if we needed 14, because there's 2 of them we can't use in every increment, right? We know that. We can't use the all zeros and the all ones, the network address and the broadcast address. So if we needed 14 IP addresses on a network, then our increment would be 16. 2 to the 4th. It's going to take 4 bits. And if we subtract 16 from 256, we're going to have the subnet mask 240. So it'll be 25. If it's a class C, 255, 255, 255, 240 would be the subnet mask. Okay, so let's just do an example. And the other one over here, we're going to do variable length subnet mask just as easily. So let's say we have a 192.168.2.0 network. How many, whatever, you either tell me how many networks you want or how many hosts you want. Because you can only specify one or the other. One's going to dictate the other. Right. If we have 4 bits for host, then we got to have 4 bits for network. If we have 6 bits for host, that only leaves 2 bits, and this is the number of bits here. So we only have 8 in each octet. So if we have 8 bits, we don't have anything left for subnetting. 8. Okay. So let's say that we wanted, make the arithmetic easy. Let's say that we wanted, let's say we want 50 hosts per network, okay? And if you do this little chart here, and when you get ready to do the test, I told you before, you have some time when they teach you how to do it that you can write some stuff down. Little chart here, we need 50, and 50 is between 32 and 64. 32 won't do it, so we need 6 bits, okay? Which is going to leave us 2 bits for network. So we got 2 bits for network and 6 for host. So that tells me my increment's 64, right? Okay?
How you know that? Okay, you automatically added 2 bits to 6.
Yes, to get the 8. Yeah, yeah. Okay, so our increment's 64, right? Mm-hmm. So our network addresses are 0, whatever the increment is. 64, add 64, we get 128. Add 64, we get 192. We add 64 again, we get 256, and that's out of the range. Okay? And if we subtract 256 minus 64 to 192 is going to be the subnet mask. So our first network is going to be 192.168.2.0, and then it's going to be 2.64 and 2.128 and 2.192, and our subnet mask is going to be 255.255.255.192. You got the subnets. Okay. Want to do another one?
Hold on.
Much easier. Wait, what you want to do?
28 networks.
The 20. So what now? You want 28 hosts per network, or 28 hosts per subnet?
Mm-hmm.
Let me get my thing up here. So we want 28. We're going to have to use the 5 bits here, right? So we'll have to use the 32. 16 is not enough.
Right.
So 28 is in here. 28, 32. The maximum number of hosts we could have here is 30, so the 28 works just fine. So our network addresses are going to be whatever. We're just working in the last octet. Dot 0, dot 32, add 32, 64, 32 is 96, 32, 8, 128, 32, 2 is 10, 160, 192, 224. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 8. See, does that work out for the number of subnets that we should have? If we have that many bits, so we have the 32. So that should take care of it. So we do 32 again, we get 256, and we're at the end. So those are our network addresses. The first usable will be 1 plus whatever this is, so it'll be .1. The broadcast will be 1 less than the next network address. So the broadcast here is 31, and these will be 33 and 63. Is that right? No, I said 31. 30. Yeah, 33 and 63. Yeah, losing my mind. So you got them. 1, 2, 3, 4, 5, 6, 7, 8, and that's right. Can be easy, huh? Because see 8. We have 3 bits left for network, and 2 to the third is going to be 8 network addresses, which is, it all works out. And we subtract the 32 from 256 to get our subnet mask. Did we do that? For 224. And if you'll notice, the last usable network address is also going to be the subnet mask. I mean, these are just a number of things that you can look at and say, yeah, did I do this right? Kind of deal.
What's the 33? First usable?
The 33 is going to be the first usable of the 32 network. It'll be 32 plus 1, and then the broadcast will be the next network address, which is 64 minus 1, which will give us the 63. So this is the usable, and this is the broadcast. So the last usable address would be 62, which gives us the numbers I think that we should have. Okay? And pause it again, and I'll put another picture up.
Okay, so what we're going to do here is variable length subnet mask. We bought a class C that gives us 256 addresses, 254 usable ones. The 0 and the 255 we can't use because we have the network address and the broadcast address. So we have 254 usable addresses in a class C network. But what we want to do is we have an organization that we need 100 addresses here, we need 12 addresses over here, and 30 addresses here. And in these, each we need 2. Now we could go buy a Class C network for each of these. And if we did, we'd really waste a whole lot here. We'd waste a lot here. We'd waste a ton of them between the two routers. So what we do is the same thing. Is we go up, and I'll roll up, and we'll look at the first one, and what the general guidance is do the largest one first. So we're going to do the largest one first, and the largest one is 100. So we need 100 addresses. If we go up here and look at this thing, to need 100 addresses, we've got to go to 128 to 7 bits, right?
Right.
So our network address would be .0. The next network address would be 128. Okay? No problem there. So I'm going to go down here, and on this thing we're going to say 128, and that's going to be the start of the next network. The next largest one that we need here is 30, right? So when we go to 30, we go up here, and we need the 32. And okay, we'll do the subnet mask. So we'll say we're going to have 192.168.0 or .1.0, and then the 128. When we subtract that, we're going to have what, a 128 subnet mask, right? So 10 and the mask is going to be 255, and I'm not going to write these every time. 255.255.128. Okay? Now the next one we need is 32. So what we can do is go down here, and if we add 32 to this, we go up to 160, right? What we're just going to do is fill them up a little bit at a time. So our next network address. we're going to make them different sizes.
Oh, okay.
Okay? So we needed 32 to get the 30 addresses.
Mm-hmm.
So if I add 32, so I'm going to have 192, 168, 168.1.128 is going to be my starting point. Because that's where the last one ended, right? Okay? So its subnet mask with 32, but it's going to be what? 224? Does that sound right?
Mm-hmm.
224. So I'm not going to write all the 255s, if that's okay.
Gotcha.
So now the next one we needed was, what, 10, I think? 12. So if we need 12, we're going to have to go to the 16.
Mm-hmm.
So if we add 16 to 160, we're going to get 176, right? Is that where we are?
You put the line under.
It doesn't matter. Whatever works for you. We put it right here in it. These are just in increments of 8. You can do whatever you want. This is just for illustrative purposes. But we do need 2 8s, so that kind of works out here, the 2 8s. So the next one is going to be 176. I jumped over here. And 256 minus that's going to be what? 256 minus 16. I wanted to say 240, and that would be right. So the subnet mask will 255, 255, 255, 240. Then we need 2 of them with 2 each, right? Mm-hmm. Now this is where this is 8s, because 2 we got to go to 4, because if we have 2 minus 2 we get 0 usable addresses.
Gotcha.
Okay? So we have to go to 4 addresses because we have to subtract the 2 each time we do this. So when we do that and we add 4 to the 176, we get 180. And then and when we subtract 256 from 4 is 252 is going to be 255, 255, 255, 252. So we get the 180, and then the next one will be, we add 4 to it, it's going to be 184 with the same subnet mask. So what we've done is gotten up here to this point, and we still haven't used all of our addresses. Since the modern routing protocols can take the subnet mask with it, they recognize these as different networks. Now, if we used a classful like RIP, which can only use the 255, 255, 255, this wouldn't work. But if you use OSPF or EIGRP, we haven't done EIGRP yet, that's next week. You can use the subnet masks or wildcard mask. Remember, wildcard mask. Actually, you know what the wildcard mask is? The increment minus 1. So if we're doing this for a wildcard mask, it would be 0.0.0.15. So when you get to wildcard mask, it's what this increment is just amazingly, makes it amazingly simple. Does that make sense on the variable length? Okay, let me pause this.